All right, so this is part of the organic portion of the practice final exam starting with number 46. It says chiral molecules are represented by, and remember a chiral carbon has to have 4 different groups attached to it. And if you look here, this carbon right here at the center has a CH3 right here and a CH3 right here, so it has 2 of the same, so that cannot be a chiral carbon. This carbon right here has CH3s attached in both places, so that cannot be chiral. Whereas this one right here has 4 different groups attached to it, so that one can be chiral. This one right here also has 4 different groups, and this one right here also has 4 different types of groups attached to it, except it's got 1 hydrogen here and 1 hydrogen here, so that cannot be chiral as well. So 3 and 4 can be chiral. Number 47. Which of the molecules below contains a chiral carbon? More than one answer is possible, and you'll find that this carbon right here has 4 different groups attached to it. This carbon has 4 different groups. This carbon right here has 4 different groups attached to it, and this one right here also has 4 different groups attached to it. So 2, 3, 4, and 5. Number 48, which of the following is not composed of 1 or more organic compounds? Ammonia. So NH3 is ammonia. It does not contain carbon. And remember, organic compounds are living or once living things that contain carbon. And crude oil, gasoline, acetylene, and ethanol are all carbon-containing substances. What's the formula of 2-hexanol? So hexanol would be 1, 2, 3, 4, 5, 6. Off of the second carbon, numbering from this direction, you'd have an OH because it's got an OL ending. And so putting these all together, we'd have 1, 2, 3, 4, 5, 6 carbons, 3 hydrogens here, 1 here, 2 here, 2 here, 2 here, and 3 right here would give us C6H13, and then we'd have an OH there. Adding this H in right here would give us C6H14O for just a formula that gives us the number of carbons and hydrogens in it. Number 50, which of the following compounds is an isomer of N-hexane? So an isomer simply means that it is a substance that has the same number of carbons and hydrogens, just a different arrangement. And the N in front of here just means normal hexane. And normal hexane would just be straight chain hexane. So 1, 2, 3, 4, 5, 6 carbons in a row with the 3 hydrogens here, 3 here, 2, 2, 2, and 2. And that, of course, would fit the normal C to the X, H to the 2X plus 2 for ane or alkanes. Now, if you draw each one of these, this is cyclohexane. Since it's a cyclic compound, one that is a ring, it would have the formula C to the NH to the 2N, and so it would be missing 2 hydrogens and could not be a isomer of hexane. In B, 2,3-dimethylbutane, butane is 1, 2, 3, 4 carbons in a row. And then we have a methyl group and a methyl group off of 2 and 3. So this adds up to 6 carbons. And then if you look at the hydrogens, you'd end up with 3, 3, 3, and 3, and then 1 and 1. So you'd end up with the same amount. So letter B could be an isomer. And then in letters C, D, and E, I have them drawn here. You see that you end up with 7 carbons, and 8 carbons, which of course would make it be not an isomer because it doesn't have the same number of carbons. Number 51. What is the formula of the organic compound represented by the line structure below? And in this one, we've got CH3, CH3, C double bond O, so C3H6O right here for letter A. And then in letter B, alkenes, those are defined as something that has a double bond. And then which is aromatic, which of the following does not contain oxygen? And aromatic would be one that contains a benzene ring, which of course is C6H6, which doesn't contain any oxygen. Aldehydes have a double bonded O at the end. I've got those over here, aldehydes right here. And then amides, those are just like acids, except they've got an NH instead of an OH here. Carboxylic acids, so organic acids, C double bond OOH, and then alcohols, COH right here. So the only one that does not contain oxygen is letter A. Letter C, which classification is generally basic? Those are amines, nitrogen-containing ones, and with the unshared pair of electrons there. And then hydrocarbons containing carbon-carbon triple bonds are often called, well, they are always called alkynes, Y-N-E, and alkynes always contain a carbon-carbon triple bond. More in the near future.